In this video, we're going to make a modular program that uses pointers instead of arrays. So we're going to learn a bit about pointers, we're going to learn a little bit more about modularity, and there's also a couple other things we're going to tie a lot of things we've learned in the past together. So it's kind of a catch-all video here. We're going to start with the mod_avg_std folder. We're going to start with that as a template, make a copy of that, and then we're going to change the name to modular_with_pointers. We go into that folder, we delete the executable, and we change the name of mod_avg_std.c to modular_with_pointers.c. We double click on it, it comes up in the editor, and we're off and running. The first thing I want to do at the top is I want to make a new function, load data. I want to do everything in a modular way. So this program is going to be super modular. So I define load data up at the top, and I'm going to make it an int. It's going to have a return value that's an integer, the number of points that were loaded up. That's going to be the return value. And if the number of points is 0, it's going to be, if there's no file, the number of points will be 0. So that's the way that load data will communicate with main. Okay, so I have two input arguments there. The first one is the file name. I just use some dummy character array there for a file name. And then AN is the array that I want to put all the data in, except it's not an array this time, it's a pointer. Star A_n is the floating point pointer that we're going to use to store the data in this program. Then, between the end of main and the beginning of calc_avg, I'm going to take that declaration statement, copy it, and then paste it down below, delete the semicolon, and then put curly braces in there. Then I do int I declare I as an int at the top, and I'm going to return I at the bottom. I is going to store the number of points, just like I did at the top. Good. After that, then I'm going to go up to main. I'm going to cut out all the stuff that to open the file and load the data and all that stuff. I'm going to cut it out and put it down in this function load data, including the declaration statement file *fp. So including that is going to be in the function, not in main. Good. There's one big difference in here if you look at the fscanf statement, right? If you look at there's no ampersand. Remember ampersand a sub I, right? Here you just have an plus I all in parentheses. There's no, but remember it's a pointer, not a regular variable or an array, and so you don't need to use the and. You just take away the star, and that's the address. So the address of the ith element of a_n is n plus I. You don't have to have the parentheses there, but I often use parentheses when I'm talking about pointers just to make it absolutely clear to the reader what's going on. So that's just a clarity issue, not necessarily, it's not compulsory that you have those that set of parentheses. Okay, so then I go back up to main. I make sure all the stuff related to file opening and reading data and all that stuff is gone. Also, the other thing that can be gone is declaration of I. You don't need an index. You don't need a counting index in main anymore. Wow, this really is a modular program when you don't even need a counter to do anything up top. That's pretty good. I like it. Next, we want to change calc_avg and calc_stdev to have all pointers instead of arrays as well. So I go up to the top, I change the array notation to pointer notation in the declaration statements of both. Then down below, if you look in calc_average, I do it at the top line there. And then the other key component in calc_avg is that in sum equals sum plus, you have the pointer notation. So star, then parentheses, a_n plus I. So that's the notation for saying the contents of the ith element of a_n as a pointer, not an array. Same in calc_stdev. You got the you have to change the declaration statements. Then also in there you can see it twice. You see it in the sum equals sum plus a_n sub I right there in that statement, but also down below in that POW thing. You have to put the pointer notation in there as well. So those are the two places inside the code that you're inside the function that you're going to have to change array notation to pointer notation. Okay, last thing we got to do, we got to go back up into main, and then we're going to declare, instead of having A as an array, a 1,000-point array, we're going to declare it as a pointer. One of the main differences between pointers and arrays in terms of code is that with pointers, you have to allocate the memory. If it's an array, you just say A square brackets 1,000. That means you're saying there are 1,000 elements to this array. But with a pointer, you have to have a function to do the allocation. And the one I use, there's a bunch of them, and the one I use often is malloc, right? So then right below the declaration of A as a pointer, you're going to do the malloc statement. So the first part of the malloc statement is in parentheses, float space star. That's called a casting statement. What you're telling malloc is you're saying, okay, allocate some memory, and I want you to make that memory tell the C compiler that it is a floating point pointer. That's what you're going to make. Then inside malloc, you actually have to give malloc the number of bytes. So 1,000, but 1,000 times the number of bytes in a float, 4. So size of float will bring back 4, so it's going to be 4,000 bytes. So you have to do that. The other thing about pointers is at the bottom, you have to put free. You have to free up that memory. So free, open parentheses, A. It's a function. Free is another function. If you forget free A, it often works, but sometimes it doesn't. And so just like fclose fp, it's an important housekeeping step to free up all pointers when you use them. So it's a little bit more overhead to use a pointer rather than an array in this case, when we're just looking at the malloc and the free statements. So that's it. That's all the changes. All the changes in the functions, all the conversion of pointer notation of array notation to pointer notation in both in terms of the context of contents of and address of and all that stuff, making sure that all that's right. Adding malloc and free. Now everything's converted to pointers in this case. Okay, so let's run it. And so I go into either command prompt or terminal. I get to the right directory, the right folder, and then I compile modular_with_pointers.c to get the executable. And I'm going to run it with 010, 0100, and 1000. You can see the results there. And it works just fine. It works just like the other program did in the past, the mod_avg_std. So that works. I want to add one more thing. I want to add error checking to main. I want to make it so that if the file's not there, I tell the user that the file's not there. In reality, we should have added error checking in all the programs we do since we learned about error checking. I don't. I'm sort of fast and loose with that, but in general, doing error checking it should become the norm for you when you're writing big-time programs. You should always have some sort of error checking step. Can the user input something wrong? Make sure you check that they input something right, and always have an if-else statement for that. Okay, so let's go back into main, and now and so when you need to do error checking, you need an if-else structure, right? Now, because we have modularized code, right, there really are only 5 lines, after all the initialization steps, there are really only 5 lines of code here. The load data step, and then the two other function calls and 2 printf statements. Modularizing code makes adding something like error checking super easy. All the indentation and stuff like that, you only have to indent like 4 actual existing statements. So change the indentation. Also, you can see the whole if-else structure in just one screen. And so it makes it super easy to add. It makes super easy to add if-else statements. Modularization also makes code super easy to read. The if-else statement, people can know exactly what's going on now. Oh, they're doing error checking, right? Whereas before, when you had a lot of things in the else statement, it kind of got lost because it was such a big else statement. Here, it's much smaller. So modularization, this is the sales pitch for modularization, right? Modularization makes things like adding error checking, adding stuff in main, much more transparent, much easier to understand, in my opinion. There's other reasons for modularity, why modularity is good, but this is sort of my ultimate sales pitch on modularity. Okay, so we go back in, we check, and it works too. The error checking works. 020, it gives no file output when you recompile it and rerun it, and so everything's good. All right, that's the end of the program. Now I just want to take a moment to comment on why I did this. I'm sure there are computer scientists and computational people who are asking that same question. Why teach a beginner in C programming about pointers? Arrays are much easier to implement. The truth of the matter is that it's not really clear if arrays and pointers are much different. If you Google it, say, what's the difference between arrays and pointers in C? You're going to get a couple of answers, and some people are going to say there is really no difference. A lot of people mix notation. They declare it as an array, they use it as a pointer, they do all sorts of stuff. And so C is really flexible in that regard. There's a lot of flexibility built into C to make a lot of interchangeability between arrays and pointers. There is truth. There definitely is truth to the concept of arrays and pointers being the same. There's nuance there. In that there's situations when they're not, and so there's all these things. It is a mistake for a professor, I'm making a mistake right now, to bring up the topic. It's not, you should not mix, in my advice, is that you should not mix array notation and pointer notation. You shouldn't mix arrays and pointers, even if it's legal, even if C will let you. It's a good idea not to do that. The main reason I did this with pointers is to just show you a good example of pointer notation in an actual example. A lot of people use pointer notation. They prefer it. Some people don't. Some people prefer array notation. And so the main reason to learn what I taught is to teach about pointer notation in all of its context. That's the real take-home message. All the other stuff about the difference between arrays and pointers, boy, it's really a minefield, and I think even for intermediate and advanced programmers, it's not that interesting. It's important to put constraints on yourself to say, okay, I'm going to stick with the pointer notation for this entire program so that now everybody knows that it's pointer notation, and you don't mix it up on them to try and confuse them or something like that. Okay, so that's the rant on arrays versus pointers. It's true that arrays and pointers are a lot alike.